All right. Hi, everyone. Hope this finds you healthy and not going too crazy. Um, kind of crazy times we're going through. So, we are going to be working on sections 4.2 and 4.3 on this video. And I think um, we're not going to be doing any more in chapter 4 from what we do today. So I am going to be having you work on a chapter 4 quiz, and that's going to be something you can do open notes, open book, just show your work on it, okay? And then we're going to move on to chapter 5. So let me just go ahead and talk about 4.2 and 4.3. You might want to review a little bit some of your dividing, long division. I'm going to do a little synthetic substitution today. So uh, this will be the plan for today, and I'll tell you a little bit more when I get down to the end of the notes on some due dates and things like that, okay? And our open discussion, which will be on Tuesday. So let me just go ahead and get started with notes here. Normally I'll use the study notes, we just don't have them for all of chapter 4, so you can still copy those off and use those if you choose, starting with chapter 5. Okay. So let's take a look at part of chapter section 4.2 we've done, but we didn't talk a whole lot about doing the finding linear factors and also finding the zeros. So with the graphing calculator. So bear with me, I've been doing a lot of talking on these videos. I have 5 classes, so bear with me a little bit. I hope it's not too annoying for you. But here, let's take a look at this first polynomial. I'm going to go ahead and put that, share my screen, and we're going to take a look at decimals for this, so you can kind of see how to put that in. All right, so I'm going to type in this equation of a negative 6x cubed, so a negative 6x cubed, okay, minus 17x squared plus 63x minus 10. Okay, and so the question on this is find the zeros. So the zeros are where it goes through your x-axis. So really all I'm looking at are these 3 gray points where it goes through the x-axis. So here one of our answers is going to be negative 5. Okay, so negative 5, 0. And then where's another 0? Well, right here at approximately 0.1670. And then lastly, right here at 2, 0. If you're using an 8384 calculator, you can go to the top of that. You have the buttons at the top that says trace, and you can hit that trace, and it will trace it through for you to find the zeros. There's also another place that you can look at to find the zeros through math, but you might just want to Google that, and if you can't figure it out, send me an email and I can help you out with it, okay, if you're using an 8384 calculator. So that's how we can find the zeros of a polynomial with using our calculators. All right, so back to our notes. So I've written those answers here, negative 5, 0, 0.1670, and 2, 0. All right, so the next thing we're going to talk about from 4.2 is determine if 2 is a 0. So remember that how you determine if it's a 0 is you use synthetic division, or you could use long division, but synthetic is quicker. And if your remainder comes out to be a 0, then yes, it is a 0. Okay, so we're going to just set up really quick here a synthetic. So remember, now if this is just written as 2, we write 2 here. If it were written as a factor like x minus 2, then we have to set that equal to 0. But if they don't give it in factor form, we can just put that 2 right here. And then over here, we want to write all these coefficients down. And notice we're not missing a term. You got to be aware of that because you have to put a 0 in, right? So here we just have a 1, and then this coefficient right here of 2, and then a coefficient here of negative 8. Remember to keep the sign with it. All right, so how we begin is we bring this 1 down, and then we multiply 2 times 1, and then we add down, and then we multiply 2 times 4 is 8, and we add down, I can read that, as a 0. So determine if 2 is a 0. Yes, it is. Now, what you might also need to do, and it doesn't ask for this, but remember, if we wanted to write it back into a linear factor, remember we started with an x squared, so we take 1 away from this power, so now we're at a 1x plus 4. And that's the linear factor. And that's what we're going to lead into next. All right, now this particular problem only asked if it was a 0, yes or no, and you have to prove that. So on a test, don't just put yes or no. All right, you can't just look at your calculator. You have to show me the work through synthetic division. Okay, so let's find linear factors. Bear with me on this DocCam. This is kind of a new thing for me, so I know sometimes I get on the microphone and it kind of is loud, so bear with me here. Okay, so let's say we have, let's go with this. We have 2x cubed minus 3x squared. And remember, this is how it is shown in your book, so I'm sure that will be similar to what you have with MATLAB. So this is finding the linear factor. So what they're telling us right here is that this 2 is a 0. All right, so I can factor out a 2 out of that, and that's what this shows right here too. So let's go ahead and use 2. Remember, we just used 2, whatever that number is exactly. And let's use the coefficients. Maybe don't forget the signs that go with them because it'll throw everything off. We're not missing any terms, got to kind of be careful. All right, so we're going to bring down this 2. And then we're going to multiply. 2 times 2 is 4. And then we add down, get a 1. 2 times 1 is 2. Add down, negative 15. 2 times a negative 15 is a negative 30. 0. So what we've done there is we've factored out a 2. But what this tells us is that if I were to look at that graph, it's going to go through the x-axis at 2. That's a 0. That's a solution. Okay. So let's write it though in linear factors. So this is kind of the new part that we haven't talked about yet. So again, we do know if we start with an x cubed and we take 1 out with a 0, we're down to an x squared. So we're going to rewrite that first of all as 2x squared plus 1x, I don't have to show the 1, minus 15. And so our goal is to finish solving this, only putting it into factors. It doesn't say actually to set it equal to 0. So we don't set it equal to 0 because we're not solving it yet. We're just finding the linear factors. So this I need to factor out. So because this number is larger than 1, we'll use the AC method. So 2 times 15 is a negative 30. All right, so we have a negative 30. And we want to find factors of 30 that are going to give us a positive 1. So we're going to use 6 and 5, positive 6 and a negative 5 to give us a positive 1. All right, so we bring down our 2x squared. Now you should remember how to do this hopefully. Plus 6x minus 5x. Don't forget you have to put that variable because I'm replacing this with these. And then bring down the last term. Right, I replace this with these. So now we have a 4 term, so we know we have to group it. So we break it apart in front of the sign. So on the left side, what do these have in common? Well, they have a 2 and they have an x. So let's factor out that greatest common factor. So 2x squared divided by 2x is x. 6x divided by 2x is 3. Bring down this sign. So remember, we're factoring out a negative there. Okay, and then what do these have in common? They have a 5 in common, so let's factor out a negative 5. So negative 5x divided by negative 5 is a positive x. Negative 15 divided by negative 5 is a positive 3. Now let's continue to factor out what each of these have in common, which is an x plus 3. I factor out an x plus 3 here. I have a 2x. Factor out an x plus 3 here, minus 5. So these are linear factors. Now don't forget, I have to bring this one down and bring it down to here also and write it as a factor. So if that's 2, the factor of it is going to be x minus 2. Oops. So I have to use 9 lead. All right, so if I bring this and remember that if I set this equal to 0, I get this. So if I'm only given, this is the 0, I have to write it in factor form for writing in linear factors. So that is your answer. Now, if I wanted you to solve that and give me the zeros, okay, this is the linear factors, but if I said, what are the zeros? All I would do is set each of these equal to 0. So x plus 3 equals 0. And then I know this solution, I can, oh, I guess I already have that written down here, don't I? What am I missing? I'm missing one. Oh, nope, that's all I have because there's only 3, right? So I should have 3. All right, so then this becomes x equals negative 3. Here I would add 5 to both sides and divide by that coefficient, 5/2, and x equals 2, which I already knew that one, but still. So these would be your 3 zeros if I was asked to solve that. So when I graph that, it would go through the x-axis at these 3 points. Okay? So that's finding linear factors. I guess maybe should we try one more? Let's do one more example here. You guys usually want more examples. I'm not sure. I don't want to waste your time, but I think it'd probably be worth it. All right, so let's look at this one. It's hard for me not to ask you questions. I have to answer my own questions here. All right, so let's say we have this, and k equals a negative 5. Okay, so if you want to pause this and you want to try it, do that. I'll go ahead and do the process and do the work for you. But if you want to practice before seeing the answers, go ahead and pause here and you can do that. All right. So we're going to divide by negative 5. And then we have 8. Okay, so we're not missing any terms, just wrote down the coefficient. So we start by bringing the 8 down. Negative 5 times 8. And then we add down. Negative 5 times 10. And we add down. Positive 15. And we add down. Okay. So let's find the linear factors. So I started with an x cubed. So that take 1 away from there, right? So now I'm going to have an 8x squared plus 10x minus 3. And now I have to factor that to find the linear factors. So because this is larger, I don't have a greatest common factor. So because this is larger than 1, we need to go ahead and use the AC method. So 8 times a negative 3 is a negative 24. Okay, what factors can I get 10? Well, 6 and 4 are one option, but if I have 6 and 4 and I need them to add it to a positive 10, would you agree these would both have to be positive? But when they multiply, they have to be a negative 24. So that doesn't work. So what are other factors that might work? How about 2 and 12? So if I have 12 and 2 and I need a positive 10, then we could do a positive 12 and a negative 2, and that then would give us a positive 10 and multiply to a negative 24. So be kind of aware of that because that's a little bit tricky right there, all right? So I'm going to replace these 10x with these. So let's bring down our first term and let's write in any order. Okay, so I just put the, whatever this variable is, I put them on here, and then bring down the last term. Okay, now we're at a point where we can group it. So let's group it. Okay, and so on this side, we have what, 4x, greatest common factor. So 8x squared divided by 4x is 2x. And then 12x divided by 4x is 3. Okay, bring down this sign, so a negative. Now these don't have I don't have anything in common aside from a 1, so I got to take that 1 out. Remember, you always have to take something out. So a negative 2x divided by a negative 1 is a positive 2x. Negative 3 divided by negative 1 is a positive 3. And we want these to be the same, otherwise it's not factorable. So what I can factor out of both of these is a 2x plus 3. And if I do that here, what I have left is a 4x. And if I factor out a 2x plus 3, I'm left with a negative 1. Now let's not forget, we've got to bring this down and put it into our linear factors as well. Don't forget to do that. So because this is a negative 5, I'm going to write it as a factor. So that's x plus 5, right? Because if I set it equal to 0, I get a negative 5. So this is linear factors. So now if I said solve for 0, solve, or set each of them equal to 0. All right, so we subtract 3 and then divide by that coefficient. Here we add 1 to both sides, divide by the coefficient, and subtract 5, which we kind of already know, because we have it up here. So here are 3 zeros. So if I graph that, that's where that graph is going to go through the x-axis. Okay. Oh, sorry about that. There we go. Okay. All right, so that is pretty much all of 4.2 with finding linear factors. Okay, and if I wanted to solve those, I would take those linear factors and set them equal to 0. Now be sure you answer the question. If it just wants linear factors, write it like this. If it wants you to solve, set equal to 0 and find the zeros this way. Okay. All right. So let's go ahead and start talking about 4.3. So 4.3 is sketching graphs. And really they're going to be polynomials, so we're going to sketch a polynomial. We're not doing all of 4.3. It gets pretty in depth, and there's a lot that we get to if we have time, and obviously we have lost class time here, so we won't be doing that, which is completely fine. It's not going to hurt you. If you are moving on to the next level course, you're still fine, so don't worry about that. So one thing I want to talk about first of all is multiplicities. And I brought it up once. I got to think how to spell it. Multiplicities. Multiplicities. That looks funny from here. Okay, multiplicities. And so multiplicities are if you have one of these, for example, but you maybe have it to a third power. That means this is a, like it could be a 0 3 times, right? If this was to the third, I'd have to take it 3 times equal to 0. But really, there's only one 0. But in a graph, how I recognize that is if I have a multiplicity that is even, okay, so if my multiplicity is even, then that means it's going to go and it's going to touch your x-axis and bounce back. So if it's coming from the bottom, it'll bounce back down. If it's coming from the top, it'll touch that 0 and bounce back up, all right? So that just means it's going to touch the x-axis, and I just use the word bounce back. And I'll show you some examples of this, all right? So if you have an odd, so like these that are 1, or maybe there would be a third power there or a fifth power, they're going to go ahead and cross the x-axis. And I usually say go through the x-axis because it goes through. All right, so let's look at maybe trying to graph some of these. Now, first of all, when we graph these, you have to remember that these are not exact graphs because we don't know the behavior that's going on between those extremes, like when we have a maximum, whether it be an absolute max, or if it's just going to be a relative or a local. We don't really know what those are right now. All right, now eventually we could figure those out. It's a lot of steps, and that's where we're not getting to. So your maximums and your minimums are not going to be the same, and that's okay because this is just a sketch. We're not looking at that behavior. we're really looking at the end behavior and where it goes through the x-axis and the multiplicities, all right? So if we're given a problem like this, let's see here, let's go with this. Now one thing I could do, and that is give you one of the zeros like this, and then you could break it down and you could find these for me. Now you wouldn't be able to do that for anything more than an x cubed, because that's all we know how to do right now. But you could do that. So if I gave you a 0, which might be something you would see, give you a 0 on this, and then you would use this and do this same, find the linear factors. So we're trying to find the linear factors. Now in this case, because some of our powers are going to be higher than 3, they're going to just give us what those linear factors are. All right, so in this case, they would write the problem something similar to this. I actually got this out of your book, so. And then they're asking you to graph that. So what I need to know is I need to go ahead and be able to solve these so that I know where they go through the x-axis. All right, so let's go ahead and solve them first of all. All right, so we know that this goes through at -1. All right, here we add 3, divide by that coefficient, so we have 3/2, and then x equals 2. So let's graph that. Again, we don't know exactly what it's going to look like, but we can tell some things on it. Remember, again, it's just a sketch, so. All right, so let's talk about a few things. So let's talk about the end behavior as a review. So we have a cubed equation with a positive leading coefficient. So remember, the cube kind of looks maybe like a chair, somewhat. And if it's positive, that means it's going to be down left and upright. Okay, so you have to be able to do the end behavior so we know where to start our graphs at. Okay, the other thing that we need to know is the y-intercept. So I can go back right here. Remember, when we find the y-intercept, we just put a 0 in for x. And so this is going to be our y-intercept. So our y-intercept, and let's write it as an ordered pair, is 0, 6. Which means I'm going to have to make these a little bit, yeah, let's do that. My graph's not going to look quite as nice as I had hoped, but that's okay. All right. So so let's start here. We know that, let's mark where our zeros are. So x equals -1. So I'm going to have a 0. That means it'll either go through or touch there. Okay. A positive 3/2 is 1 and 1/2. So somewhere in here, approximately. And then x equals 2. So really close. My graph's really close there. So it's probably not going to look great, but that's okay. And then we know that it's going to go through the y-axis at 6 here. Okay, so those are kind of the points we know. This is going to be kind of hairy right here because it's really close. But we know that we're going to start down here, and when we're done, we're going to end up here. Okay, now because these all have a power of 1 for our multiplicities, that means they're all going to go through the x-axis. They're all going to go through the x-axis. So let's start down here. And all I know, and I know that this, all I know is that this is going to somehow go through this. I don't know how high we're going to go here, so I don't have to worry about that so much. But I'm going to come back down, and I know it's going to go through this point, and then it's I don't know how low it's going to go, but it's going to come back up here like this. So it's going to look something like that. Now, you might look at it on the calculator, and it's going to look way different here and here. All right, because we don't know what those max and mins are. So we're not worried about the behavior from here to here or from here to here. We just want to see that it goes through the x-axis. We want to know where it starts and where it ends and what our zeros are. All right, so that's why if you use a calculator, your graph is going to be exact, and I know that's not correct. I mean, you of course have to show me this work, but if you just type it in a calculator, I know that you did it incorrectly because it's not, I don't expect it to look like what it would in a calculator. Okay, does that make sense? So let's go ahead, let's do another problem here. All right, let's do this example. Let's see what I have here. Let's try this one. Sorry, I have to kind of turn that for my writing. We'll do a P of X in front of that there. Okay. Now, I don't really know what that is. I mean, maybe I do, maybe I don't, but we haven't talked about how to do an X to the 4th. So they give us this part, which is nice. So I don't even have to use synthetic division. All I'm doing is graphing that. But we do need to know a couple things, right? So we need to know the zeros. So let's find the zeros. So that means we set each of these equal to 0. So how do we undo a square? Well, we square root. So if I square root this and I square root this, that's just the square root of 0, which is 0. So x is equal to 3. Same thing here, square root plus or minus 0. Remember, there's a plus or minus, but it doesn't matter because it's just 0. So x plus 3 is equal to 0. So x equals a negative 3. Okay. So you do need to show me that work. So I know the zeros. Can you tell me what, let's go ahead and figure out, we need to know the end behavior. So let's look at end behavior. All right, so we got a quartic equation, so an x to the 4th, and we have a positive coefficient. So remember, if it's even, your end behavior is going to go the same direction. And if it's positive, they're going to go up. If it's negative, they're going to go down. So I know that it's going to go up and it's going to go up, but I don't know what happens on this behavior in the middle here. I don't know any of that extrema stuff, and that's okay. And then the y-intercept, I put a 0 in right here. So that's what's really nice about having this equation rather than these. If I put a 0 in here, I can just see, holy cow, it's going to be at 81. So 0, 81. Just so you know, folks, I'm not going to graph that at 81. Okay. So let's take a look at the graph. Let's see, let's put it over here so we can have a little bit of room. Now I am not going to go up to 81. Okay, I'm just not. But let's look at our zeros. All right, so this would just go way up high. All right, so let's mark our zeros. We have a 0 at 3 and a 0 at negative 3. And then we have a y-intercept that's way up here. All right, we don't know, but it's way up there at 81. So we know we're going to start up here. Okay, now think about this. These are even. So when we talk about our multiplicities, what did we say when our multiplicities are even? They're going to touch the x-axis and bounce back that same direction. All right, so that means we're going to start here somewhere. We're going to come down, and instead of going through, because it's even, it's going to hit that and it's going to bounce back up. And we're going to go way, way, way up to where our y-intercept is, probably even past it. We don't know how far exactly, but, and then we're going to come back down somewhere. And because this was also even, we're going to touch it and we're going to bounce back up. And our graph will be something like that. Now, it's not going to look at all like this on the calculator because we don't know what that behavior is. We don't know if this goes a lot higher, or if it just barely goes. I mean, it can look a lot different. But what we do know is our end behavior, and we know where it goes through the x-axis, and we know our y-intercept. Okay. All right. So let's do one more. Okay, let's do one more example. All right, so we got that. And now I could have, actually, no, not on this one because it's an x to the 4th and we don't know how to do it. We can do an x to the 3rd, but we can't do an x to the 4th right now. So here's what that factors out to. So let's talk about the zeros first. Okay, so the zeros, set each of them equal to 0. So subtract 1 and divide by a coefficient. Here we just add 2. Okay, here we got a square root, right? Plus or minus, square root both sides. So x is equal to a -1. So those are our zeros. Let's look at what our end behavior is. What's our end behavior? Think about it. We have even, positive. So it's going to be the same as our last. And then what is the y-intercept? The y-intercept is, if we put a 0 in for each of these, we end up with a -2. So 0, -2. That's a little bit better, right? All right, so let's look at this one. All right, so let's go ahead, and it's kind of nice to be able to spread them out if you can, because then you can give yourself a little bit of room when you're graphing. But all right, so -1/2 is right here. +2 is here, and a -1 is right here. Again, as I said, there's not a lot of room. And then we have a y-intercept of -2. All right, so let's look at our power. So here on the -1, which is this one right here, it's going to do a bounce and go back up because it's got an even multiplicity. Okay, so the others are powers of 1, so they'll go through the x-axis. All right, so we know we're going to start up here, and this is -1. So -1 is where we're going to bounce back. So we start up here, we come down, and we're going to bounce back up. Now we don't know how high we're going to go. Totally fine. Just do whatever, come back, and we know at -1/2, it's a power of 1, so we're going to go through. And we know it's got to somehow go through that y-axis. We don't know how far down it goes. And then we get over here to 2, we know it's also a power of 1, so it's going to go through and continue on. So something like that. I mean, it looks awkward and it looks kind of funny, but we don't know this height and we don't know this minimum, and that's okay. All right. So let's take a look at this last one. So this one is saying, okay, I'm going to give you a graph. So given a graph, find the linear factors. Okay, so we're going to write this as a function, but we're going to write it in linear factor form. We're not, you don't necessarily have to multiply all those together. So, I'm going to give you a graph here. I think I've already got a graph ready to go. Let me show my screen. So here on Desmos, let's go over to this one. All right, so here's the graph that you were given. And I assigned one of these similar to this, so I wanted to show you this. So what we have to know, right, is we have to know the linear factors. Well, the linear factors are where they go through 0. So we're going to look at this point right here, and that's a -2, 0. All right, so I'll write this down here. Okay, and then what is this 0 right here? 1, 0. And then what is this 0? Is a 2, 0. Okay, I'm going to come back to this in just a second. So looking at our notes, these are the zeros. So remember, when I write it in factor form, I have to put them back into factors like this. So if it's a -2, would you agree that's going to be x plus 2? Because if I set it equal to 0, it would be x equals a -2. Okay, this one's going to be what? A x minus 1. And then this is going to be an x minus 2. And that's all they're asking for is linear factors. Now, if they wanted the equation for it, I would have to multiply this times this, get that answer, and then multiply it times this. But I'm not going to have you do that. It's very time consuming, and we really don't have a lot of time to do some of this. So I just wanted to show you that's exactly what we got here for the graph, is what we found with these zeros. It's really that simple. As long as you can find the zeros, you're in good shape. All right. All right. So that, you guys, is all I have for your sections 4.2 and 4.3. Now, I have posted in your pages, all pages, chapter 4. You have an assignment that's labeled 4.1 to 4.3 worksheet. All right, and what it is it's some problems that are signed out of the book that are really good problems. So you have to show your work on them. Even if you have answers in the book, you have to show your work, all right? Because you're not learning if you don't. And I'm not there to give you a worksheet to walk around and check your understanding on it. So the only way I know if you're getting it or not is by your homework. So you have to show your work for me. And I will tell you that 4.1, and it's on your syllabus, and it says 4243. This is your new updated syllabus that I emailed out to you. But it's really going to be 4.1 to 4.3, and that's going to be due on the 15th. And what you'll need to do is you just need to either scan it or take a picture of it and email it to me. And so you'll then still have a copy of your work, which is nice. Okay, and I don't care how you do that. But what I want you to maybe just think about and kind of be considerate of is that I have over 100 students. I have 5 classes. And so I'm going to be getting a lot of emails for some of the work that we're doing. And I hope to have it organized in folders. I kind of have it set up. And I will try and get your homework in as soon as I can. And then on Tuesdays, when we have our open discussions, we'll have those at 5:30. Then you can ask any questions that you have on your assignment and you still have them. Okay, so be sure that you come to this first open discussion on next Tuesday. Again, it's on that syllabus, and then we can talk about what we're going to do from there and the expectations for you. Okay, this is just your study notes, so I'm not going to get into that right now. But also let me tell you that you have a quiz, a chapter 4 quiz, and it's open book, open note. It's also in the chapter 4 assignments under pages, all pages. You can just show your work on that as well. And again, email that into me for chapter 4. Okay. All right. So that is all I have for you today. So I will continue to work on the study notes for your chapter 5. But we'll talk about on Tuesday any questions you have on these assignments that I will be posting today. All right, you guys, have a great one. We'll see you later.